All right, guys. All right. So we're not delving into chapter 4 yet. We're not going to start chapter 4 till after Thanksgiving break. But before then, I thought it'd be nice to cover something that y'all actually, it is still math. It is still stuff that is good to know. It will show up on the ACT, but y'all find it a little more interesting than some of the stuff we've been going over. Matrices. Matrices, we have covered these before. We talked about them at the beginning of the year. It's a rectangular arrangement of numbers. Now, we're going to talk a little bit more about them because there is more information or properties to them. So we did talk about the fact that a matrix has rows and columns, and we define the dimensions of a matrix by rows and columns. Now, a matrix, we always use capital letters to name it, A, B, C, D, E, F, however we want to name it. Lowercase talks about the elements. So each number inside a matrix is an element. And the numbers after the letter, the lowercase letter, is row, column. So if we said A31, it'd be element in the third row, first column. So for this here, that would be 7. Or if we said A22, second row, second column, in this case would be 3. So dimensions is our rows by columns. If we have a lowercase, we're talking about the element, the individual number inside the matrix. So if we were looking at this here, use matrix A to answer the following questions. If we wanted to know the dimensions of this here, it would be what? We have 2 rows by, so it'd be A2 by 3.
Oh no. This is easy, bro.
Questions on part A? Part B, find A2, 1. So since we're talking about lowercase a, we're talking about the element. So we're going to go to the second row, first column. So we go second row, first column is 9. So A21 is 9. Second row, first column.
Oh, I didn't see it.
Yeah, find the value of A21. Questions on these here? Are you ready for the next one? So we're going to use this matrix to, 1, state the dimensions first. So what would the dimensions of this matrix be?
3
3 by 2. 3 rows, 2 columns, so 3 by 2. Now it also wants to find the value, wants us to find the value of B, 3, 2. So we're going third row, second column, which would be -1. Because 3, 2, so we go down to the third row over 2. Yes. Sure. Now, if it had said B22, if we wanted to know the value of B22, what would that be?
That would be 19.
19. Second row, second column. Down 2 over 2. Questions on stating the dimensions or finding an element? Now, there's special matrices that we've given kind of special names to. First one is a row matrix because it has exactly 1 row. A column matrix, we call it a column matrix because it has exactly 1 column. The next special type is a square matrix. A square matrix, we call it because the number of rows and the number of columns are the same. It makes a square. And a zero matrix, we call it a zero matrix if every element in the matrix is 0. So they're all zeros. Are kind of some of our special types. Some that we've given special names. Now the next thing we're doing is adding matrices. Adding matrices is nothing new. We've added them before. We did this at the beginning of the year. It's been a bit. But the only way we can add or subtract 2 matrices is if their dimensions are the exact same. So if we're saying A plus B, we'd take our matrices 16, 2, -9, 8, and add it to negative 4, negative 1, negative 3, and negative 7. So we're adding these two together. Now matrix A is a 2 by 2. Matrix B is a 2 by 2. But we can't add them together because the dimensions are the exact same. And when we add and subtract, we add the corresponding elements. So we'd add 16 and negative 4. We'd add 2 and negative 1. We'd add negative 9 and negative 3. And 8 and negative 7. We add the corresponding elements. We add the elements that are in the same location. Now the last thing we need to do is simplify. So 16 plus negative 4 is 12. 2 plus negative 1 is 1. Negative 9 plus negative 3 is negative 12. And 8 plus negative 7 is 1, telling us our result. The answer for this is 12, 1, negative 12, 1. Questions on this here? Because the other way we could have done this is we could pull the calculator up. We went second matrix. We went over to edit and defined it as a 2 by 2. And A was 16, 2, negative 9, 8. Once we typed it in, we went second quit. Second matrix. Since we have two of them, we'll type the second one in as B. And we had negative 4, negative 1, negative 3, and negative 7. Once we got them both typed in, or got the second one typed in, we went second quit. Now what we're doing is we're taking matrix A, because the first list of matrices lets us recall them. So I say A plus B is 12, 1, negative 12, 1. Now when we did this the first time, we realized, and still realize, that typing in addition of just two matrices is about as fast as actually just doing it by hand. There's really not a big difference between adding or subtracting if we're just doing it by hand. Now once we start throwing scalar multiplication or doing scalars and multiplication, scalar multiplication with addition, subtraction, then it starts becoming a little faster for the calculator to do it. Let's look at this one here. Matrix B, negative 4, negative 1, negative 3, negative 7 is being, we're having it and we're subtracting from it the matrix C, which is this here. Matrix B's dimensions are what? 2 by 2. Matrix C is a 2 by 1. Are the dimensions the same? So this here is what? Not possible. Not possible. Can't do it. Questions on this here before we move on? We have A plus B plus A. A and B are both 2 by 2s. 16 to so when it's saying A plus B plus A, we just replace A with its matrix, we replace B with its matrix, and then we'll replace A with its matrix also. A plus B plus A. Now we can do this two at a time, but again, we're adding and subtracting the corresponding elements when we add or subtract matrices, yes? So that's still true if I add 3, isn't it? So really, I'm going to be at 16 plus negative 4, yes? And then we're adding to it 16. I'm just taking that first element in each and we're adding or subtracting. We're doing the opposite operation between them to those corresponding elements. Since it's just addition all the way through, we're just adding those three. The same with our next one. We're doing 2 plus, -1 plus. Our next one is -9 plus, -3 plus, -9. And lastly, we have 8 plus, -7 plus 8. And we can do 16 plus -4 plus 16 by hand, or the 30xs, 84 plus, I can type 16 plus -3 plus 16, yes. Or -4. 16 plus -4 is 12. 12 plus 20, 18. Sorry, 12 plus 16 is.
To the front office. Sidney Lower, Brandon Williamson, David Haggard, Tristan Morgan, Dominic Billy, Ethan Russell, Dylan Tiki, Jose Rosa, Jonathan Legee.
Let's do the next one. 2 plus -1 is 1. 1 plus 2 is -9 plus -3 is -12 plus -9 is -21. 8 plus -7 is 1 plus 8 is. Now this here is starting to get to where we're starting adding a good bit, because we could have done what also? We could have come in, we could have defined A and B in the matrix C, yes? And gone what? Second matrix A plus second matrix B plus second matrix. We get the exact same thing. We just let the calculator do the calculation. Questions on this here? One A, can we do these? Can we actually subtract them? Yeah, it's a 2 by 2 and a 2 by 2, yes? So what are we subtracting? -3 minus -4, our top left, top left. Our next one we have is 4 minus 12, top right, top right. Then we have -9 minus 8, and lastly, -5 minus -7. Now we do have some double negatives here. If we struggle with double negatives, -3 minus -4, we can throw it straight in the calculator, but a negative and negative make a positive. Let's undo that. So it's really -3 plus 4, giving us 1. 4 minus 12 is -8. -9 minus 8 is -17. And -5 minus -7. Negative makes a plus, giving us. So really each one of those elements that we're combining or having to simplify are 3 minus -4, 4 minus 12, -9 minus 8, -5 minus -7. Calculator will do each one of those. So we could type it all in as two matrices, let it do the whole A minus B, or we could just do the individual element subtractions and additions. Questions on this here? I might as well go on and do 1B, because we have a 2 by 3 and a 2 by 3. So we'd have -9 plus -4, 8 plus -3, 3 plus 6. -2 plus -9, 4 plus -5, and -7 plus 18. -9 plus -4 is -13. 8 plus -3 is 5. 3 plus 6 is 9. -2 plus -9 is -11. 4 plus -5 is -1. And -7 plus 18 is 11. Questions on addition, subtraction? We feel comfortable with addition, subtraction. I mean, we've done addition, subtraction before. This is nothing new. Well, one of the other things we did before was scalar multiplication. When we multiply a matrix C by a scalar, so we're saying 5 times R, we're multiplying every element, so 5R. We're saying that we're going to do 5 times this matrix. Or in other words, we're going to take every number, every element in this matrix, and multiply it by the scalar. And the scalar for us is 5. So when we scale something, we're going to either make it bigger or smaller. Scale models, because it's scaled down. Or we can scale it up. So here, every element in that matrix C, we're multiplying by 5. So we have 5 times negative 12. And 5 times negative 12 is negative 16. 5 times 8 is 40. 5 times 6 is 30. 5 times negative 16 is going to be negative 80. 0 to 3, yep. 5 times 4 is 20. And lastly, 5 times 19 is going to be 95. But again, we don't have to do that by hand or do it in our head. We can just do that in the calculator. Calculator will do it. Because a lot of stuff, especially on the ACT, yes, we can do it in our head. Yes, we can get to the answer. But sometimes it's better, faster, and more sure we just plug it in and let the calculator do the work. Especially if it can get to the answer faster than we can. We're on a time, especially ACT is a time test. So any seconds or any amount of time we can save is more time you can use on a later problem. Time wasted on a problem is time you don't have for another problem. Let's look at one more scalar. If t is equal to this matrix C, find negative 4t. So our scalar for this is negative 4. So this here is telling us to multiply every element in that matrix E by negative 4. Now the first thing we can do is we can come over and say negative 4 times 8, negative 4 times 0, negative 4 times 3, negative 4 times negative 2, negative 4 times negative 1, negative 4 times negative 4, negative 4 times negative 2, and negative 4 times 9. But realistically, what are we going to do? We know we need to multiply every element in that matrix E by negative 4, yes? Because that's all it's asking us to do. We might as well just start typing it in, negative 4 times 8. If we can type it in the calculator, it'll tell us it is negative 32. Negative 4 times 0 is 0. Negative 4 times 3, negative 12. Negative 4 times negative 2 is positive 8. Negative 4 times negative 1 is 4. Negative 4 times negative 4 is positive 16. Negative 4 times negative 2 is positive 8. And negative 4 times 9 is negative 36. Questions on this here? Now, it might happen that one of these shows up on the ACT. They ask you to do this here. But again, anytime you're solving problems on the ACT, keep an eye on the answer choices. Because we know for this here, the dimensions of this matrix E still have to be a 2 by 4, yes? So any matrix E that's not a 2 by 4 is wrong. We can remove it, yes? And as I start looking at the elements, if the first one, that top left, is not negative 32, it's a wrong answer. If it doesn't have 32, 0, negative 12, as we start filling them in, we can start with the answer choices. And again, there's a good chance you could get halfway to 2/3 of the way through multiplying this out and have the correct answer and be eliminated down to 1. But questions on this here? We good with this here? Yes? Commutative property, we can add 2 matrices in any order. We can add 3 matrices in any order. Left scale and right scale distribution work. We can multiply by the left or the right. Now, when we start talking about scalar operations and addition, subtraction, I have a feeling most likely this is when we start really reaching for that calculator, yes? Because this is when the calculator starts getting faster than we can do it by hand. Because if we wanted to do this by hand, we're going to have to multiply b by -4, and then subtract 3 times a from it. So first thing we're going to do is multiply this first matrix by -4. Now I'm going to write it out because we would have -4 times -4, -4 times -8, -4 times 2, and -4 times -3. Then we'll multiply the second matrix by -3. Now we could have just multiplied it by 3, but when we take the negative with it, the sign between it's just going to turn into plus. So our -4 times -4 is going to be positive 16. -4 times -8 is positive 32. -4 times 2 is -8. -4 times -3 is 12. -3 times -9 is going to be positive, not 18. That's 27. -3 times 12 is -36. -3 times positive 2 is -6. And -3 times positive 6 is positive 18. Now, since they are the same dimension, we can add our corresponding terms. So 16 and 27 we're going to add together. 32 and -36 we're going to add together. -8 and -6, 12 and 18. 16 plus 27 is going to be 43. 32 plus -36 is -4. -8 plus -6 should be -14. And 12 plus 18 should be 30. But again, it's not that this is a lot of complicated steps. If we take each step nicely, it does work out nicely. But there are a decent number of steps involved. Would we agree with that? So let's see here. If we're doing this in the calculator, what would we do first? Second matrix. Over to edit, we're going to put the first matrix in. We can put it in AN. So -9, 12, 2, -6. Second quit, second matrix. Over to edit, we'll put the second one in as B. we have negative 4 second matrix B minus 3 second matrix A. 43, negative 4, negative 14, 30. Isn't that the same thing we got? So especially when we start doing multiple matrices with addition, subtraction, and scalars, starting throwing a lot in, the calculator starts becoming a little bit faster, yes? Yeah. Questions on this here? Do we want to do this by hand or in the calculator? Walk through it in the calculator. So we have two matrices here, both A and B, yes? So what we can do is come over here, we need to define matrix A. So second matrix, over to edit. We're going to select the first matrix C, and it is a 3 by 2. Nice thing with typing those in, because it is sometimes easy to flip the rows and columns, is it gives us a picture, because we need 3 down, 2 over. And we'll type them in, negative 5, enter 3, 6, negative 8, 2, 9. And it's nice to hit enter after we type each number, because it just bumps us to the next spot. Once we get it typed in, second quit, second matrix. Over to edit, we'll put matrix B in. It is also a 3 by 2. 12, 5, 5, negative 4, 4, negative 7. Second quit. It told us that we have negative 6 B plus 7 times matrix A. So we get 107, negative 107, negative 9, 12, negative 32, negative 10, 105. Yes? Questions on this here? Now again, with matrices, when we add or subtract, the dimensions have to be the same, yes? So even with scalar multiplication, if it asks me on the ACT, negative 6b plus 7a, simplify the following expression using our properties of matrices, we know the dimensions, one, have to be the same for us to be able to even be able to add or subtract, yes? But the dimensions of our result should also still be a 3 by 2, yes? There's a good chance they're going to give us a few matrices that are 2 by 3s. When we know those are wrong, we can cancel them out, get rid of them. We can start using the answer choices that they give us on the ACT to get to the answers without factoring or doing anything, actually solving it. And as we solve it, I would still pay attention to the answer choices and see what we get. What's different, what's the same. Because there's a good chance that the answer key is actually going to give us good hints to get to the answer. Does that make sense? And that's what we know and more about how to take a test. We ready for something new? Multiplying matrices. To be able to multiply two matrices, the rows of the columns of the first has to match the rows of the second, because it's rows by columns. So if the columns of the first, the number of columns we have in the first matrix being multiplied match the number of rows in the second, you can multiply the two together. And the new dimensions is going to be rows of the first by columns of the second. That's what it's telling us here. If columns matches rows, our new dimensions is going to be rows by columns. Over, down, over, down. And I will tell you this here already, because if they ask us to multiply two matrices together, graphing calculator has already been able to do addition and subtraction. It can do multiplication too. So if we look at this here, A and B, we want to see if we can multiply. So columns of the first has to match the rows of the second. A is a 3 by 4. B is a 4 by 2. Columns of the first is 4. Rows of the second is
Jaden Brown, please come
4.
to the office. Jaden Brown, please come to the office.
So this tells us, yes, we can multiply these two together. When columns of the first match the rows of the second, it says we can multiply. The rows of the first and columns of the second tell us our new dimensions. So columns of the first, rows of the second say they're both 4, so yes, we can multiply these two together. That's all it's telling us. Rows of the first, columns of the second tell us what the new dimensions are. So yes, we can multiply A and B together, and the new dimensions are 3 by 2. We don't know what matrix A and B are at the moment, but we can say that they are able to be multiplied together. B. Columns of the first is 3. Rows of the second is, are those the same? No, so this is not possible. Columns of the first has to match rows of the second. If it does, we can multiply. If it doesn't, we can't. Yeah, Darcy. Let's look at 1A. Columns of the first is 6. Rows of the second is, since these are the same, it says yes, we can multiply it. And our new dimensions for AB, rows of the first is 4, columns of the second is 2. So our new dimensions when we multiply these together is going to be a 4 by 2. Which is kind of nice to know, because if it's asking us to multiply two matrices together, one, we can be able to say, does the columns of the first match the rows of the second? If it does, we can multiply it. Then we know the new dimensions. We know what the dimensions of the answer have to be. Any of them that are not those dimensions are out. It gives us ways to help us get to the answers. One B, A is 3 by 2, B is 3 by 2. No. We could add them. We could subtract them, because a 3 by 2 and a 3 by 2 have the same dimensions. So we could definitely add these two together. We cannot multiply them. Questions on this here? Question on anything we've done so far? How we actually multiply, the way I think of it and the way I keep it straight, it's over down. We go over the row, down the column. And corresponding elements in the row and column that match up. And when I say corresponding, so first row, first column is going to multiply with first row, first column. First row, second column, we got to flip it because we're going down. It's going to be second row, first column. We go over and down, over, down, over, down. So I'm going to use highlighters because we're going to go over and down. Multiply the elements that are kind of corresponding to each other if we took those two and went over. And that gives us first element. And we're going to go over and down to get this here. And we keep going over, down, over, down, over, down. As many rows and columns as we have. Same thing is true with our second row. We'll go over, down, over, down. And that will give us our corresponding spots here. Questions on any of this here? It just says evaluate, doesn't it? Nope. Nope. Now, bless you. Now, I'm going to be nice. Now, most likely, I'm just checking. Yeah. What you're going to do for most of the multiplication is one, like we know how to do, we've been doing it for a while, on and off now for a while, is plug it in. We plug in, the first one is A, the second one as B. So we're doing A times B. Now, since they're both 2 by 2s, they can multiply because rows of the second does match columns of the first, 2 and 2. New dimensions are going to be 2 by 2. Huh? That's the second way to do it because that's the values of A, B, C, so I'm doing it by the quadratic formula also. So there's going to be some that asks you to solve by factoring, some ask to solve by quadratic formula, 2 by completing the square, and then some by graphing. You're going to need to know how to do all of them. All right, guys. Focus in, focus in. So if we did this here, it will do the multiplication for us. It'll do the multiplication for us. All right, guys, focus in for a little bit longer, because what we're going to do is we're actually going to multiply. I'm going to show you how we would multiply this by hand. Because if we multiply this out, to do the multiplication, we go over and down. So we would start with top left, which would be 6, and we would multiply it by -5. And we would add to it -3 times 3. If there was another number after -3, if it was, say, 4, we would multiply it by the number under the 3 in the second one. So we keep going over and down. Now, once we finish doing that, we're going to do first row, second column. First row of the first matrix multiplied by the second row of the second matrix, second column of the second matrix. So we'd have 6 times -4 plus -3 times 3. And we would keep going if there were still numbers below 3. Questions on this so far? Now, if there was a third column on that second matrix, again, we would go over and down. We would keep going with that first row with each column that the second matrix had. Then we kind of understand how we got that first row of our new matrix, yes? Once we run out of columns in the second, we go to the second row of the first, and repeat the process. So we're going to have negative 10 times negative 5 plus negative 2 times 3. Try and see why I call it over down. Because we go along the row, down the column. Along the row of the first, multiplied by the column of the second. And then we're going to do it one more time. Negative 10 times negative 4 plus negative 2 times 3. Because I think we can start seeing at this point, basic addition, subtraction, doing it by hand, do it in the calculator, do it all in the graphing calculator, neither one of them was really necessarily significantly faster than the other. Can we say multiplication is definitely faster in the calculator? Yeah. Because now we've got to simplify. 6 times negative 5 is negative 30. Negative 3 times 3 would be negative 9. 6 times negative 4 is negative 28. 24. I don't know where I'm getting 28 from. Negative 3 times 3 would be negative 9. Negative 10 times negative 5 is positive 50. Negative 2 times 3 is negative 6. Negative 10 times negative 4 is positive 40. Negative 2 times 3 is 6. And lastly, negative 30 minus 9 is negative 39. Negative 24 minus 9 is negative 33. 50 minus 6 is 44. And 40 minus 6 is 34. We'll finish this tomorrow, but I think we noticed that calculator is a better option.